we have a spring connected to one end of the track. End, we have a smart cart connected to the spring. A string is connected to the other end of the cart. The string goes over a pulley, and there's a hanging mass. Built into the smart cart is a force sensor which is connected to the spring. Force is recorded on the top digital meter, as well as the y-axis of the graph. Position is on the bottom meter and on the x-axis of the graph. I pull the cart back until I can see zero force, and when I get to zero force, I restart the data taking. The reason for this is that the zero for the position is set wherever the cart is when you start the data taking. There is currently 100 grams of mass on the hanger. The force sensor reads a little bit more than it should because it was not properly zeroed before I began. I'm going to add weight 20 grams at a time until the hanging mass is 300 grams. Each time mass is added, I will record force and position. First, I will record the initial force and position. Now, I will add 20 grams more. And record force and position. I continue doing this until I get to 300 grams. Somewhere in the middle, I get off by 5 grams. I need to change the graph scale to properly see the data. The origin of the graph is in the bottom right corner. This means that the positions are all negative and the forces are all positive. This is because the positive direction for the cart is to the left in this setup. The data for this part of the lab will be given to you in an Excel file. Set up are 3 plot areas, one for position, velocity, and acceleration. All 3 share a common time axis. I found spring forces using masses from 100 to 300 grams. So I'm going to start with a mass of 150 grams on the hanger. The cart has a mass of 250 grams. I'm going to displace the cart from equilibrium, then let it go, but I want the equilibrium position at x equals 0. So I'm going to start the recording before I move the cart. I'm going to adjust the position scale so that it reads full scale. The data for these graphs will be provided in an Excel file. You will have to remove the part of the data from before I let go of the mass. Now I will use a mass of 250 grams. This data will also be on the Excel spreadsheet. On the left are two graphs, acceleration and force, that share a common time axis. On the right is a graph of force versus acceleration. I'm going to zero the force sensor in the equilibrium position so that what I'm really looking at is the additional force as it's taken outside of equilibrium. The hanging mass is 200 grams. I'm adjusting the scale on the force time graph. Now I will adjust the scale on the right graph. This data will be provided on an Excel spreadsheet.